For as long as humans have existed, we've looked up into the night sky searching for meaning, patterns, and our place in the vastness above us. To truly understand the universe, we need to look at it in more than just the light our eyes can see. Think of this Van Gogh painting. Every color contributes to its story and its beauty. Now imagine seeing only a single color. The painting becomes dull, reduced, incomplete. The universe is just like that. If we observe the sky in only one kind of light, we're only seeing a small part of its story. To study that full story, astronomers look at the entire sky around us, like a sphere. We then unwrap that sphere into a single, flat map, so we can see and compare everything at once. This is our sky. The whole celestial sphere stretched into a single view. Light comes in many kinds, or wavelengths. Some of them we see as colors. Most of them are completely invisible to our eyes. When we change the wavelength we use to make this map, different layers of the sky appear. Glowing gas, stellar nurseries, distant galaxies. And at the longest wavelengths, in the radio light, the familiar sky transforms into something far richer and more surprising. Radio waves reveal things that ordinary light can't. The glow of energetic particles, jets powered by black holes, vast structures that stretch across galaxy clusters. LoTSS, the LOFAR Two-metre Sky Survey, maps all of this across the entire northern sky. The latest release, LoTSS Data Release 3, is our most detailed radio map yet, revealing over 16 million radio sources. But how do we make an image like this? We need a different kind of telescope. This is the radio telescope LOFAR. It is currently the largest radio telescope in the world, realized on initiative of the Netherlands. The core of LOFAR is right in the middle of the countryside in Drenthe, though this field of antennae is just a small part of the complete instrument. LOFAR combines the signals of 52 stations in 8 different countries to create a Europe-sized telescope. The heart of the operation is in the Netherlands, with 38 stations. Germany has 6 stations, Poland has 3, and other stations are in France, the UK, Ireland, Sweden, and Latvia. Additional stations are due to be built soon in Italy and Bulgaria. All these stations send their data to Groningen. With all this collected data, we can construct a radio map of almost the whole northern hemisphere. Piece by piece, we discover what's hiding in the radio universe. The richness of LoTSS cannot be overstated. As we take a journey through its impressive catalog of over 16 million unique radio sources, we discover a variety of wonders the cosmos has to offer. Our journey starts within our home galaxy, the Milky Way. And where better to begin than with worlds beyond ours? Exoplanets. We do not see these planets directly in radio light, but we can detect interactions between them and their host stars. If you're lucky, you've seen Aurora Borealis, the northern lights on Earth, a spectacle of planetary proportions which emit bright radio waves. So bright, in fact, that we can potentially use LOFAR to observe similar phenomena on planets beyond our solar system. Detecting these auroras would offer a glimpse into the planetary conditions of these distant worlds. The presence of auroras are a sign of a strong magnetic field, which shields the planet from harsh radiation coming in from its host star. By studying these auroras, we can begin to understand whether a planet has such a protective shield, which is a key ingredient for maintaining an atmosphere and potentially supporting life. But the Milky Way is only the beginning of our journey. LOFAR reaches far beyond our home galaxy, revealing distant, powerful objects. Black holes reside at the center of many galaxies. Here, a mixture of gas and dust swirls in around the black hole until it eventually falls into it. Some material, however, gets redirected and shot out from the top and bottom of the black hole. These jets of material are massive and can be bigger than entire galaxies. Even long after the black hole stops blasting out material, their smoldering remnants faintly shine radio light LOFAR can observe. With LoTSS data, astronomers can trace the history of these black holes and learn how they shape the galaxies around them. When we look further out, LOFAR reveals a huge number of galaxies so distant and so faint that they can only be seen in radio light. Galaxies from the early universe, billions of years before our solar system took shape. By studying this ancient light, we deepen our understanding of how galaxies originally formed and evolved. And as we zoom out from these early galaxies, we see that they gather into much larger structures, vast groups of galaxies known as clusters. Finally, let's take a look at the big picture. Now, the large-scale structure of the universe comes into view. By counting how many radio sources we see in different directions and how strongly they cluster together, we can trace the largest pattern in the universe, the cosmic web. From galaxies to clusters to the cosmic web, radio astronomy done by the LoTSS reveals structures and objects we could never see before, adding a new layer to our cosmic picture, uncovering details of our universe and opening up many intriguing questions to explore. So, get ready for the LOFAR Two-metre Sky Survey.